like on those ticks? Going in the fire compartment. Just under 300. Okay, so tick speed, heat signatures. Okay, so it's reading surface temperature of whatever's right there. Watching the leak start to open compartments, and you actually start to shoot the open hole of that like windows, it's going to read a much higher temperature. So what that means is if the surface of that wood feels like 300, not that that room is 300. Okay, that room is probably higher than 300. All right, let's see what happens here. So we're going to try to show how there's unburnt fuel in the smoke. Watch that thing puff, it's choking, right? It can't get enough oxygen in, so it'll burp, it'll let some oxygen in, then burp again and let the smoke out, right? Kind of like when you take a Coke can and pour it upside down, right? It can't let all the liquid out, unless you do what? You have to do what you call it, right? Unless you put a key in the top of it and open a ventilation hole. All right. This is what you do. See the smoke color change? Still not quite giving us what we want, but it is letting us know that there's more burning, right? The volume of the smoke has changed. You were listening earlier, when you open up number 4, see number 4 again? Is the volume of smoke thicker? Totally, right? That's more poisonous, more toxic to our victim. What's that? Okay. Sorry, this is one thing we're going to show. The rest of the stuff is still super valuable.
It's hard to see what they're doing, Paul. Now the smoke's lighting up. But if we open that door to three that was compartmentalized, we clean everything in the female three is still in the wall. Or if we just left it closed, everyone has gone in there.
So what's happening? Go ahead and open back up, Leo. Fire is now going into 3 from 1, right? What is that concept called? Direct flame, it's not on the board. How about this? There's a couple different terms for it. Auto exposing, right? That compartment wasn't on fire, but what happened?
Those trees.
The fire from the flame 1 came out and went back in. We talked about this, I think, in your building construction lecture. Where did we see that recently? A high-rise fire, right? Davis Street, the first one, 2 years ago. And watch how quickly this spreads. Dry Christmas tree. How quickly it goes from not involved to involved. testament to keeping water in your tree, okay? We just lit in a couple spaces. That could be a shorted electrical cord, a discarded cigarette, unattended cooking. Burning pretty hot? Can you feel the radiant heat? All right. I'm going to move this a little closer because I'm worried my experiment won't work. You guys feel radiant heat on your face? Yes, sir. Put a glove up on a part of your face. You cool down?
Yes, sir.
Okay? That's the value of shielding. Something to think about again in a structure fire. If you're really, really hot, can you get behind a pony wall? Can you get behind a door? Can you get out of the way of the fire? Because my face is super hot. I put this up to it. I'm giving myself some shielding.
Let's try. Look at the left edge of the right tree.
Who wants to go? Come on, baby.
Who wants to go?
I don't think it's gonna get it. Dang it, not enough energy. I'm gonna show you direct flame impingement instead. Didn't quite give me radiation, but you get the idea. That Christmas tree go up fast? Yes. Let's take a look at this one. Probably like 10 seconds. The thing is gonna be a ball of orange, and then it'll be completely burnt out. Burning pretty efficiently. Yeah, we don't see a ton of smoke coming from this, so it's releasing a ton of heat. Try that experiment again. Feel the heat against your face. Put a glove up. Okay, that can represent your hood. That can represent a building, a piece of the building. Get yourself away from that radiant heat. Protect yourself from potential burn injuries. Oh yeah,
Over 1,200 per.
Guess it now. Tick says too late.
Snowing.
Let me ask you this though. Did all the fuel burn? No, right? I mean, what do you put on fires? Logs? What are we staring at? 2 logs? Okay? So another concept, we want to make sure we fully extinguish the fire, because if we turned our back on this fire, could it potentially get hot enough and relight in a room? Yeah. That wood is still flammable. Okay? The reason, why didn't that wood burn, but all the needles burn?
Too dense.
Density, right? So we talked about that before. Wood frame, ordinary constructed buildings versus heavy timber. The denser the material, even if flammable, the more it will resist fire. So all those needles, very thin, not dense. Burn super fast, very easily, right? They're dry, so they don't have moisture, and they're dense. This stuff, super dense, resisted the fire.